Okay? Clear? I'm interested in bridge. Well, I'm not actually. I'm very bad at bridge and all other card games. But that's because when it's my turn, I spend 3 hours trying to figure out the odds. And this question is, find the probability that a bridge hand, that's 13 cards picked at random from a normal deck of 52 cards, has at least one ace. And I have two answers here. Answer number one, which is very tempting, and I like it a lot. I like a lot of things that are wrong because it makes life simpler. Answer number one, choose an ace. How many ways can I do that? Well, obviously 4, choose 1. I've now picked an ace. And then all I have to do to ensure that I have at least one ace, I can pick any one of the remaining 51 cards. 51 choose 12 ways. So I've chosen an ace here, and I chose the remaining 12 cards here. And of course, that's divided by the number of ways of getting a hand of 13 cards taken from a deck of 52. That's it. That's the answer. Well, is it? What's wrong with that? Yes? Oh, I see what you're saying. When I add up the two top numbers, 4 and 51, I get 55. And I started with 52 cards. But let me try the logic again. I have 52 cards, it's true. And I'm trying to figure out ways. I mean, this is a standard approach to solving these combinatorial problems. I'm trying to figure out ways of dishing out a hand under the constraint that there be at least one ace. So what I did was I set aside the 4 aces and I selected an ace from that. And now I took those 3 remaining cards and I put them back in the deck because there's no constraint on me having exactly one ace. I can have 2 or 3 or 4. So I put the 3 aces that were left back in the deck and picked a total of 12 cards out. So that's really the explanation for the numerator. That 51 is what I had left after I drew a single ace out, and I replaced the 3 aces into the deck. Anything else that you may or may not like with this answer? Yes?
I'll be aggressive next time.
Sorry? I said at least one ace, yes? I could choose 2 aces, but you see, this is actually, so the answer, the suggestion is that when I carried out this calculation, I'm permitting 2 aces. I could, among those 12 cards, choose another ace, or 2 more aces, or 3 more aces. But that's what the question asked. I want to have the probability of at least one ace. This is a standard kind of problem, yeah. Exactly. You have to watch for this in all the problems that you do. Many of them, any kind of complicated problem, be careful that you don't double count something. How am I double counting? Well, in the denominator, I'm simply using the total number of hands of 13 cards. But what have I done in the numerator? For example, I could have picked an ace of hearts first, right? And then, among those 12 cards remaining, I could have picked an ace of diamonds. Or I could have picked the ace of diamonds first, and then, among the remaining 12 cards, the ace of hearts. I've counted that combination, that possibility, twice. And if there were 3 aces, I've counted it potentially, I think, a total of 6 times or something. In any case, I've overcounted the combinations in the numerator. So be very careful in these combinatorial problems. Here is a safe way to solve such a problem. In fact, you'll get used to this very shortly. A question involving at least one ace or more, 1, 2, or 3 or 4 aces. So take the complement. What's the complement? The probability of no aces at all. It turns out that's much easier to solve. How do I calculate the probability of no aces? Well, of the 4 aces, I have to choose 0, so that explains the 4 choose 0. And now of the 48 non-aces, I have to choose 13 cards. So the numerator is the number of ways of obtaining 13 cards from a deck of 48 non-aces. The denominator, as always, is the total number of points in my sample space, which is 52 choose 13, because I'm selecting 13 cards from the total deck of 52. So this is the probability of no aces at all. The complement of that, of course, is the probability of 1 ace, or 2 aces, or 3 aces, or 4 aces. So 1 minus that probability gives me the probability of at least 1 ace. Sorry?